Alright, I want to show you how to navigate around Logger Pro a little bit. I have here a sample data set, and let's just see exactly what we're looking at here. If we click on the label, we go down to More, we see that we are looking at run number 3, position versus time curve here. And down here, we see in velocity, we're also looking at run number 3. So how many runs are there? If we come up here, this is the data browser right here. So we pull that up and we see that there are 4 runs. Actually, in this particular data set, only runs 1 through 3 have data in them. So that's one way to see it in the data browser. Or you can come over here to the table on the left and you can see that there are data in run number 1. Let's slide this scroll cursor over, and we see run 2 and run 3 all have data. I guess by default it comes up showing the last run that has data in it. So now what we'd like to do is add a calculated column for the kinetic energy and for the potential energy. So to do that, we can go from the data browser and say add new calculated column, which is this button right here. Or we can go up to the menu to data and say new calculated column from there. Both are going to bring us up to the same dialog box, which is this one here. And we want to call this one kinetic energy. We'll give it a short name KE, and the units for kinetic energy will be joules. We want to work off of data set number run 3, and we can add this to the other data sets at the same time if we want. And the formula for kinetic energy is 1/2 mv squared. Well, velocity is already a column of data, but we need to add the mass. So we're going to go here to parameters. That's basically a variable. We'll say edit and add, and we want to add mass. So we can call it MASS or just M if you prefer. And the value for the mass of our ball in kilograms, it was 780 grams, so that's 0.780 kilograms. And that will have 3 decimal places. I don't know what this is. Don't know what that is, but don't worry about it. And while we're here, we might as well add, didn't have to leave that box. Let's add the acceleration of gravity because we'll need that for the potential energy. So we can call that G. That has the value 9.81 meters per second squared. Maybe that's what this is. Per second superscript 2. Yes, meters per second squared. Okay. And now we're back here. So our formula for kinetic energy is 1/2 mv squared. So we'll put in 1/2, 0.5. We could put in 1 divided by 2. Times mass times, and we want to pick velocity, and that has to be squared. So we could put velocity times velocity or velocity caret, which is shift 6, 2. 1/2 mv squared, and click done. And we see now we have kinetic energy column in here. And if we look over here, we see our kinetic energy column. Okay? And the value is very small. It's very low until we start to get our ball moving with a reasonable velocity. And we can plot kinetic energy versus time. Let's change this out. We'll get rid of velocity and we'll put kinetic energy on there instead. And there's our kinetic energy. And we see that it goes down. Kinetic energy goes down and then it starts increasing. And let's do the same thing now for a new column for gravitational potential energy. So we'll go here, we'll say new calculated column. This is potential energy. call it PE. The units will be joules. And we'll add this to run number 3. And potential energy is mgh. So we can pick the parameter mass times g times the height, which is our position variable. And then we will say done. And we see there's our potential energy. Let's close our data browser. And let's plot potential energy here. And we see that the shape is very much the same because it is just multiplying a constant factor, but the units are different here. Potential energy goes up to, well, we can find the data over there, but it's going to go up to about, looks like maybe 12 joules or 11.5 joules. Okay, whereas when we were looking at position, we only went up to 1.5 meters. Okay, so hopefully that information will give you enough to do your data analysis. Remember that you can select your data and zoom in. We zoom in there, and we can zoom in on this graph for the same data. So now we're on the, should be on the same scale. Well, maybe I didn't select across both graphs. But you can fiddle around with it and figure it out. All right, good luck.